Hey folks, Chuck Black here. We are doing 52 weeks of Python. We are in week number 28, and the topic for this week is Napalm. We're going to talk about how Napalm provides for you a level of abstraction in hiding from you the details of device communication and the differences between different devices so that you can talk to multiple products within the same vendor, and even you can talk to different vendors in the same way. We're going to look at code that does exactly that. As we go through this code that communicates with network devices, we are going to force you to become a Python developer, not just somebody who can copy and paste code and try to make it work that you get from a website or whatever, but you will become a software developer through doing this. We're going to learn even about try except functionality within Python in order to catch errors that get thrown. And we're going to look also at how Quokka uses Napalm, because it does use it in its device communication. So all that is coming up in the next session, in this session right here. So without further ado, let's get started. Okay, so let's start talking about Napalm. Now, as you can see over here on the left, I have code that we're going to be looking at. But before we look at that, we need to understand this and make sure that it's solid in your mind. So I've gone over this picture before when we were just starting with all of this stuff, but I want to make sure that it's clear as day to you. So Napalm, how does Napalm fit in all of these things? Well, when we talk to devices, some of the abstractions that we want are, we want our library that we're utilizing to handle the details. So for example, Paramiko handles the details of SSH handshaking, and NetMiko handles some of the details of actually logging into the device and getting to the point where we can enter commands to show stuff or to do stuff, whatever. So we want to be able to not have to worry about all of those details. Another thing that we want, and this is where Napalm begins to show its strengths, is we want to be able to have the library handle differences. So we want to be able to say, get me your interfaces, or get me your interface counters, or get me your general information. And we want to be able to do that through our package and have it figure out, how am I going to do that? This is a Cisco iOS device. This is a Cisco Nexus device. This is a Juniper Junos device. How am I going to get that information? Ideally, we don't want to have to be recreating that over and over and over again. This is a fundamental tenet of software development, is you want to do things once and then let everybody else utilize it. That's why we have functions. That's why we have packages. And that's why something like Napalm existed. Somebody said, you know what? Everybody's having to do this. What if I created a library or a module that people can utilize, and from this package with the different functions that I'm going to put in it, they will be able to then make a single call and get similar information back, and they don't have to worry about the details or the differences. That's what we want. Now, we would like to have some type of common interface. Of course, Napalm has its own interface. NetMiko has its own interface. When we go to the next page, you'll see PyEasy, NXAPI, all of these different libraries and packages have their own interface, so we don't really have that. But what Napalm does do that these others don't is it supports multiple products. So in the same product family, probably the closest thing that I can think of here is with PyEasy, you can make one call, and it doesn't matter what type of Junos device it is. I can't even remember the names. There's SRX and there's MX and EX. I think I'm getting that right. Juniper, this PyEasy library, will figure out how to get that information from all of these devices. It would be nice if Cisco had something similar, because Cisco has devices that it has acquired, that it has built from different business organizations that all have different data defined, and that would be nice. But going back to Napalm here I'm on my second slide. This is Napalm, and I've expanded what it's able to do. I do want to be able to support multiple product families, and even better, I would like to be able to support just multiple vendors with this single API. And that is what Napalm claims to do, and it does a pretty good job of it. Doesn't matter if I'm going through SSH, if I'm going through some other netconf type mechanism to the device. Sometimes it uses NX API. My interface is going to be the same. And that is what we are going to see when we begin to look at the code. Okay, so let's look at the code here. Now, the first thing I want to touch on is this. Remember from our NetMiko code that we were looking at, that would be the NetMiko example right here, we used this connect functionality that I created. I called it NetMiko Connect, and it was in this connect module. And NetMiko Connect looked like this. Now, I've commented out all of these things. You notice I'm in this connect module, and what I did was I took this thing that I called Cisco Sandbox Device, maybe appropriately or inappropriately named, and I moved it out and called it Cisco Sandbox Devices, because really there are multiple devices in there. And I put exactly the same thing that was in there inside this function outside here. And what I did was I made it available so that in my Napalm code, I can say from connect, that's the library that I was at. I'm going to control B and I go down into connect. I'm going to import this Cisco Sandbox Devices. Do you see this? I say import Cisco Sandbox Devices, and those are what I'm going to use when I'm doing Napalm. And so what I've done is I have created code that is going to iterate through all of my devices, and it's going to use Napalm to connect to them. And we are going to demonstrate how with Napalm we're able to use, we don't have to worry about the differences of the device type, we don't have to worry about the different product family. It's all within the same vendor. That's because I don't have different devices. I would like to get a GNS3 or something up and running so I can have Juniper and maybe HP as well as Cisco devices happily running, but I don't have that expertise, so I don't have that set up yet. But right now, I do have these cloud devices that we're using. They're both Cisco, so I'm not doing multiple vendor, but I am doing multiple product support. And some of the stuff that we are going to be doing through Napalm is going to be using NetMiko to talk to the device, and some of it is going to be using NX API. And so we are going to actually be experiencing that. And so that is why I made the change to connect. Now, this is going to be different from if you've downloaded the code from my GitHub repository to look at, and you did that immediately after I published the NetMiko example, you might want to get that information again, because I did change connect. You can see here I've commented out this stuff, and it works the same. NetMiko still runs fine, but I made it different so that I can have access to these and not have to be redefining this all over the place. Now I have one spot to get access to all of these devices. So that's what I did right there. Now I have a nice comment here. This is, let me give you a little bit of information about comments. And we haven't talked a whole lot about this, but this is an important Python thing that's actually an important coding thing. If you have a line of code that says something like I equals I plus 1, you do not need a comment that says increment I by 1. That's obvious. Everybody can read that. But when you have some stuff that people might not otherwise understand what actually is going on, then you need to have a comment. And here my comment is saying that we're going to disable the insecure HTTP requests that Napalm gets. So Napalm gets these insecure access warnings. It's in the Napalm code. I can't change that, but I would like my output not to be cluttered and littered with these warnings, so I have disabled them here. And this is, I just looked up online with the warning that I was getting. You can kind of see, because you would have seen if we don't have this, you get insecure request warnings. I just Googled that with respect to how to disable them or what to do about them, how to fix them. and they said the easiest thing to do is to disable them. All right, so that's what this is, and that's why I have a comment there. Like going back to my comment about comments, it would be silly for me to say set capital iOS to the string small iOS. That's obvious. You can read that in the code. You don't need to do that. But for something like down here, you may say to yourself, why is Chuck doing that? And we'll get to that in just a second. Here's my constants. Remember, constants are not a thing in Python other than by convention. So I'm saying iOS is going to represent that string. NXIOS is that string. NXIOS underscore SSH. Now this is different. Why am I doing this? The reason that I have this is because Napalm needs to make the distinction. If you want to communicate with your Nexus device using SSH only, then you can use this thing right here for creating the driver. If you want to use NX API, then you just use NXOS. So there's a distinction there. And so what I'm going to do, my Cisco Sandbox devices, how many devices are those? If I do Control B, I'm going to see, oh, well, there's only 2 devices there. And look at this, there's the port. This looks like these are both defined for SSH. As it turns out, the credentials are going to be exactly the same, and the host name is exactly the same for using NX API as it is for using SSH as we're doing here. So I'm going to be able to try to reuse that. What I'm going to do is I'm going to make a copy of my Sandbox devices. Now, I probably in retrospect didn't need to make this copy, but the thing is I want to be working with my own version of this. I don't want to take any risk of mucking up this Cisco Sandbox devices. If I did make changes to it and somebody else were to come in and try to use that, I'm the only one doing it here, but if we were sharing this, I was sharing this with other people, then I might be screwing around with their data, and I don't want to do that. So I make a complete copy. And remember from, I forget what week it was, but we talked about nested data structures and about assignment versus shallow copy versus deep copy. If you want a complete copy, then you need to do a deep copy. And if you're really sharp, you could probably look at this and say, well, I guess I do need to do a deep copy because it's actually 2 levels deep. If it was only 1 level deep, remember that's the difference between shallow copy, which is called just copy, versus deep copy. So I needed to do the deep copy there. Now devices is my brand new data structure that's pointing to something different. Now what I'm going to do is I'm going to actually add another device to my list of devices. Right now I have 2. When I do this, I will have 3, and one of them will be NXOS underscore SSH. That's the one I'm going to use for my SSH communication. So I now have, at this point in time, I'll have 3 different devices, and I'm going to iterate through those. And all I did here was I made a complete deep copy of the NXOS one. The reason that I'm doing a copy here, and I probably could get away with not doing it, is I intended to modify one of them to remove this port item. And I determined that the code was actually more confusing to get rid of the port item in my one that doesn't need it, the one that is not doing SSH, this one here. I realized that it was going to be harder to just go ahead and delete that in my mind than it was just to have an if statement. And all I do is I do something special here. And if it's an NXOS device, that means I'm using NX API. That means I'm not using the port. And so I do this. And if it's any of the other types of devices, I use this. There's multiple ways to do this. We could argue about the best way or the worst way, but that's what we're going to do. But before we get too deeply into that, let's take a step back here at the code that I went over, and let's talk about how you do things and get things done with Napalm. Okay, so let's look at what I'm doing here. What I'm doing is I'm iterating through all of the devices in this thing that I created called devices, and it originally had 2. Now it has 3 items in there. And this is how we iterate through a dictionary. Remember, to going through a dictionary, we get two values. We get the key and we get the actual object or the value that we're interested in. And the way that we reference it when we're trying to make it iterable, make a dictionary iterable, is we do dot items. So we call this built-in function items, and that allows us to iterate through the dictionary. So I'm going through my devices dictionary one at a time. Now here's the magic of Napalm. What do I have to do to talk to a device? It's very simple. All I have to do is I call into Napalm and I say, get me a network driver that is of this type. What are the types? Well, the types are going to be iOS, NXOS, or NXOS_SSH. That is what Napalm has defined as the strings that represent different device types. Now, if there was Junos, then there would be a Junos one. If it was Arista, it would be EOS. If it was HP ProCurve, it'd be something different. I don't know what all of them are. You can look them up, but this is a magical string. It's not magic in any way other than it identifies to Napalm what type of device driver does it need to create, because that's what we're doing. We're getting this thing that Napalm calls the driver. Okay, so we get the driver based on the device type, and from that driver I'm going to create this Napalm device, and I'm passing in this information. So here we're actually doing object-oriented stuff, and we are creating an object which has a host name equal to our device host name, a username equal to the device username, and a password equal to the device password. That's if it's an NXOS device. If it's iOS, or if it's NXOS SSH, then we're doing SSH. And as we know, then we're going to have to pass in these optional arguments, which are the actual port. And that's what I need to pass in. That is my device with the key of port. If you want to remind yourself here, this is the port. This is the value that we're referencing. In both cases, it's 8181. And so at the end of this code, whether I do NXOS or whether I do any other type, I'm going to have something that we call that I called a Napalm device. And it was created by taking this driver thing that I got and passing in these parameters. Okay? So this is all the magic of object-orientedness. It's going to give me something called the device, Napalm device, which I can then use to do generically retrieval of various pieces of information, and I can also set them as well. But in this example, I'm only going to be retrieving information. And so my Napalm device, my first step was to do this, get the driver. My second step was to use this driver that I got and to create an object that I'm calling a Napalm device that is going to represent my actual device with the appropriate hostname, username, and password. Once I have done that, then all I need to do is do an open on that Napalm device. And the open, as you can imagine, if it's doing SSH, it is going to establish a connection, an SSH connection with that device, doing all of the handshaking and getting everything ready for me to issue commands. If it is doing something like NX API, then it will do whatever is required by NX API. I know absolutely nothing about NX API, but I'm using it here because Napalm hides. Remember, it does a great job of hiding for me all of the details of how I have to deal with that type of communication. If this was a Juniper device, then I would do exactly the same thing, except my driver, my device type, would be Junos, and my driver would therefore be a Juniper driver. And when I passed in the hostname, username, and password, it would do all of the netconf communication for me. Remember this picture? It does whatever is necessary to communicate with the device. So Napalm is doing this magic for me. Once I have opened my device, so I'm doing napalm device.open I am able to then proceed with doing all of the different device communication things that I may want to do. Before I get down into getting the facts, interfaces, etc., I want to take a look at what we've done here. I hear you saying, Chuck, wouldn't it have been easier just to hard code everything and call things directly with my hard coded values for getting the network driver and doing an open and all that other stuff? Why are you adding in all of this stuff? And my answer is, well, I can hear you kicking and screaming along the way, but I'm attempting to make you into a software developer, not just someone who can copy and paste code from a website. So we are trying to learn Python as we go, in addition to learning all of this cool Napalm, NetMiko, etc. stuff. I strongly advise you to learn this stuff because you will be so much more valuable to your employer or to yourself should you go into business by yourself. It's an order of magnitude change to be from a copy and paster into a software developer. And that's why I'm doing things like having you import Cisco Sandbox devices from this connect file, and having you do a deep copy and understand what deep copy means, and having you do a for loop through a dictionary of all things, and then having you dereference the device information so that you're getting at this host name and the username, etc. And all the different things that we're doing right here, the F strings. This is to help you to get beyond just a copy and paster and to become a software developer. So I strongly encourage you to make sure you're understanding what I'm talking about here, and don't just say, oh, Napalm's easy, I just do get network driver and it's good. I want you to not only learn that, that's fine, but I want you to learn about the rest of this as well. So here we are. We now have our Napalm device. What does the next stuff look like? Well, guess what? There's really not a whole lot left to this file. This is all there is. We go down to the end and we do a close. What are we doing? All right, here's another situation where I am dumping stuff on you that's going to make you have to learn software development. And it's not really that difficult, and we've done it before, but I will go through this again. So I print out this string facts, that's fine. But now I do a print statement, and inside the print statement, I have this json.dump_s. And then within json.dump_s, I'm using my Napalm device. And not only that, within that, I'm calling get facts. So look at all these different parentheses. I have one level of parentheses, two level of parentheses, three different levels of parentheses, all nested here. Why are we doing that? Well, I could do these all on separate lines, but you will find that people tend to like to write concise code as long as it's readable. And for me, I think, and hopefully for you, once you get to be intermediate level developer, this will be totally readable. We start from the inside and work our way out. The first thing that we're doing is we're taking our Napalm device. So we've opened a connection to the device, and we are telling Napalm, I'm calling this function called get facts. It's actually a method, but I want you to get me the facts for this device. And what's going to happen, the result of this is going to be a Python data structure that is going to be in a format that is common across all the different devices. It will have facts about serial number, software version, etc. It's going to return this, and then we are going to take that information, and I'm actually doing a json.dump string. So I could have just printed this normally, but instead I'm bundling in this JSON stuff. If you wanted to, you could just print this just as it is and not worry about anything else. But I decided to use JSON because we've just learned JSON a little bit ago, and now we're making use of it. You'll see people ending up doing this. If you go to Stack Overflow and look for solutions to certain things, you will see some people will temporarily translate stuff into JSON simply because it's easy to deal with. Why is this easy to deal with? Well, I can have it sort my keys for me, so that's kind of nice. and then I can tell it how far I want it to indent. So I'm doing this with all of these things. Now, getting back to Napalm, what am I actually doing? All I have to do with my device, remember, I created my device appropriately, and all I need to do is say get facts, and it will figure out all of the messiness about how to get the facts from the device. I sit up here and I say, get me your facts, and it comes back, Napalm comes back and on a platter with Python data and says, here they are. Doesn't matter if it was talking to a Juniper device or to a Nexus device or to an iOS device or whatever it is. Napalm does that exactly for me. So here you can see I'm getting facts, getting interfaces, getting VLANs, getting SNMP information. I don't know that there's any interesting SNMP information out there, but it's one that's available. And whoa, hang on a second. Look at this. This one is a little bit different. Let me take a minute and explain this to you. All right, so you look at this code, and I actually can't remember if we've gone into this in even minor amount of detail before, but you see try, except, whoa, what's that all about? What's going on? Well, in Python, as in other programming languages, if you encounter in your code something that you don't understand or that seems wrong, instead of just crashing, you can throw an exception. So you catch a problem and you throw an exception. And if you throw an exception, that gives the calling code an opportunity to catch the exception and to do something about it. Because if you don't do that, your program will crash and it will stop running. And that's exactly what's going on here now. As it turns out, remember how I said how cool it was that you can call and make one method call or function call and get the information back? That's great, except for the fact that not all devices support all different requests that we may make in this manner. In fact, if you were to go out to your Napalm documentation, napalm.readthedocs.io, you would come to a page here that talks about supported devices, and you can see here's a number of devices that are supported, Arista and Junos, and a bunch of different Cisco ones. I think that they have other ones supported, but I'm not 100% sure. Talks about configuration support, of course, with a lot of caveats. And then getters, well, this is when we go and get information. And guess what? I can get ARP table information from an iOS device, but I can't from an iOS XR device, or from a Junos device, or from an NXOS type device. But I can if I'm using SSH. That's kind of interesting. So the one that I'm looking at is get interfaces. So here we go, get interfaces. Is that what we're looking at? I'm trying to remember. Get interfaces counters. So if I were to go get interfaces counters, here we are. It's supported. Oh, here's one where it's not supported. Guess what? NXOS does not support get interfaces counters. And so that is where I could either not make the request, or I could actually just catch the exception and say, oops, looks like it's not implemented. And when you do an except here, you can just catch any error and print something out and continue. But if you know what type of error you're looking for, like in our situation, we're looking for a not implemented error, then I can print out a specific error message that says, oops, this wasn't implemented for, and I can give the device host name. I might want to put in here the device type as well. That would probably be even more useful than the host name. And I print out the error. Anyway, this thing in here is exactly the same as this thing right here, which is exactly the same as this thing right here. Now, by the way, you may have noticed, here's my print statement with my opening parenthesis and closing parenthesis on the same line. Here, a print statement actually is separated, and I have the beginning and ending parentheses on different lines, and I have the insides of the call on its own line. Why is that? Well, one of the reasons for that is that's what some of the formatters do, and I've installed this thing that I think I mentioned before. I might have only done this in the Quokka walkthrough, but I have this thing called a formatter. There's three main ones. The one that I tend to use is black, not because it has anything to do with me or my name, but simply because you don't have any choice. You can format it any way you like, as long as the way that you like is exactly like the black formatter does it. But it's very, very popular. I can't remember if it was contributed by Google or Facebook or if they just use it, but yeah, it is very popular. And so that's why this is separated. And here you can see you got the same thing. In fact, not only that, it separated the print statement, but it also separated the JSON dump S statement. So again, we've got beginning and ending parentheses. So you don't have to worry about this. It's exactly the same as if it was on one line, but it went further than the formatter decided it liked it, and so it formatted it like this. All right, that is my try except for interface counters. Now, what about for this one right here? I have another try and except. Why do I have that? And what am I catching? Well, I'm catching different types of errors here. And the reason that I'm doing that is because Napalm seems to have a bug in it for communicating with the Cisco Sandbox device. Because if I go over to my supportability matrix and I look at Get Environment, look at that. It says everything supports Get Environment. So there should not be any errors. But what I have experienced is there is a powers up key that does not exist in the specific device from which we're getting this data, the Cisco Sandbox device. And I can't remember if it's a Nexus device or Nexus SSH or iOS. I forget which one it is, but it throws that error. And so rather than having the program barf and die, I decided to catch that error. And then we go to the next device. I close this one and we go to the next one. And that's all this is. I'm doing it for every device that we have. This is our Napalm. What do? We say napalm.getNetworkDriver, and we pass in the device type. Device type is going to be a string, one of these or one of the others that we just saw. Once I have my driver, I can create my device using the driver and passing in the important information: hostname, username, password, port if necessary. Now I have my Napalm device. All I need to do is open it, and you can do it just in this manner. Once I've opened it, then I can call napalmdevice.getFacts, get interfaces, get VLANs, get SNMP information, etc. And I had to add extra code here in order to catch exceptions. Okay, so the next thing that we're going to do is attempt to run this code and see if it works. Now this, I'm going to warn you, takes a while to run. So I'm just going to stay quiet while it is running, and I may decide to speed it up for you when I actually create the video. So let's let it run here. Okay, so I've set this to go at 3 times the normal speed. So when you see connecting, it really took 3 times as long as that. There you can see the facts. I'm printing out the interfaces, VLANs, SNMP. There's a little bit of data, interface counters. And finally, we're doing the environment here, and it will give us temperature and power and all that other stuff. Now it's connecting to NXOS. This is using NX API. And if you watch, you see fax takes forever. So the communication with NX API, for whatever reason, takes a really, really long time, in addition to the fact that some stuff isn't quite implemented. But there we got the fax, so you can see that. Now it's waiting to get the interfaces back. So we will see interfaces in just a moment or two. There's all the interfaces, VLANs, interface counters. You can see I'm highlighting wasn't supported, and powers up key was missing, so that failed. Now we're in the NXOS device using SSH. Things go much faster. It already did the basic stuff. It's done the VLANs, done SNMP. It's doing the stuff at the end, the environment. So just to finish up this Napalm example, we ran through all 3 devices. We got all of that information. The stuff that we got was, let's see if I can remember what they were: facts, interfaces, VLANs, SNMP information, interfaces, counters, and environment. And just going backwards, here's the environment for the last one that I did. Interface counters wasn't implemented, so we caught that exception. SNMP information, this should look familiar if you understand SNMP. This looks like VLAN information. I'm just taking a stab in the dark. People are messing around with VLANs on those devices. So yeah, there's all the different VLANs. Here is, these must all be all of my interfaces, I'm assuming. There certainly are a lot of them. I'm scrolling up and up and up and up and up and up and up. Jeepers. Yep, interfaces. So the basic idea, and this is just the general facts, so you can see that we got a lot of information doing it the 3 different times. I connected to NXOS SSH, and I did the same thing for, initially my connection was to my iOS device, and then I connected to the just NXOS without the SSH, and I got the information. So the nice thing is I didn't have to know all the different gory details about communication. They were taken care of me by Napalm, and all I had to really worry about is doing this creation of the network driver based on the device type, and then creating this device out of the driver. And once I had opened it, then I was able to have a channel of communication to the device in which I could get facts, and didn't matter what type of communication was going on underneath, it did it all for me and gave it to me in a nice Python data structure. So that's the advantages of Napalm, and truly I'm sure you can see they are tremendous advantages, the things that you don't have to worry about. It's really nice to just have to worry about your own code and not have to worry about all the different details. That's why in this area here, if I go to the previous slide, if I go to the previous slide here and we look at it, then you can see here you had to worry about your code, but you also had to worry about login, command differences, output differences. Once you get to Napalm, all you really have to worry about is your code. Yeah, there was a little bit of setup stuff that we had to be aware of, but once we're done with that, we could just get on with doing our code in whatever manner we felt like doing it. Now, a question you may be asking is, does Quokka use Napalm? And as you can see from this picture that's in the Quokka wiki under implementation, we do actually show that when we talk to devices, we are in general using Napalm. Now, this picture isn't 100% complete because sometimes we use NC Client just to demonstrate that. But in general, I've chosen to use Napalm for communication with the various devices that I am monitoring. And so when you come up here and look at Quokka and look at the user interface, you can see I have this pesky CSR device that's out there in the sandbox that's supposed to be always on, but isn't always, unfortunately. If I go here and I say display device status, and you can see that its availability seems to be coming up and down periodically, but be that as it may, I'm going to attempt to get information from this device. Now, when I click on facts here, it's going to give me the information that I've stored already, because I go and get facts and store it in the database. So if there's information in the database, I will go out and get that information. But if I wanted to get it live, then I will do this, and you will see that it does indeed take a little while. On average, I think it's been taking something like 12 to 20 seconds to get a response out of the devices. Now, if you recall, it showed that the device was down, so I'm not sure if we're going to be able to get that information, or this could spin forever because it's not responding. But we'll give it a little bit more time. Well, it seems to have come back. Anyway, I'm not sure if any of this information is different. I don't recall what uptime. Maybe you guys that have it on the video can go back and check it out. But it said that we got that. Let's go see if we can get ARP information. Once again, the wait here, it needs to connect to the device, and you saw how long that took earlier in the example code when I was looking at Napalm. And once I've connected via SSH, then it needs to go out and get the data. Sure enough, it got that data, so that's good. Counters work as well. These are actually the first things in Quokka that I implemented, strange as it may seem. Quokka now has grown to be something that monitors things in the background and does packet capture and stuff of that nature and hosts and services. Originally, all that I was intending to implement was to go out to a device and get information, but it has grown and I guess blossomed or whatever into something much more than that. But here you can see that I did get the counter information. And lastly, I will go, and this is something that's not in the example. Not sure why I don't have it in the example, but one of the nice things that you can do with Napalm is say, get me the running config. And so that basically goes to the device and does a show running config and presents you with the information. And shortly you should see that presented here on the screen. So here's the configuration information for that device. Let's see, this device didn't have a whole lot of interesting stuff. There's a number of interfaces that we can look at. It was the Nexus device that was a little bit more interesting. So speaking of which, let's go back to the devices. Now this device here, I'm kind of manually doing netconf, so I'm not using Napalm at all for this one. So we're going to ignore that for right now. Now my Nexus device that's out there, I'm using the SSH version to get at information. So here I am at the main screen. Remember, fax, it's just getting it from the database, so that's pretty quick. ARP table, I just looked at this a second ago. I thought that ARP was not supported, but I remember when I did NetMiko, I had to say show IP ARP, and it worked. So maybe Napalm has been changed so that it is supported. And sure enough, I found a couple of entries in the ARP table. If I was to go and get counters, I'm not sure if this is supported. It's possible that I may be getting an error response that says it's not supported, and it may not be getting forwarded up to my user interface, and consequently this would be a bug in my code that it just sits here forever and spins. And I think that's probably what is going to happen here. So in 5 or 10 seconds, I think I'll give up and get the running configuration. Okay, I give up. Let's go see if we can get the running configuration, see if this works a little bit better. Once again, it's usually about a 10 or 15 second wait for it to come back. And there it is, running configuration. Now, if you recall, it had a whole bunch of stuff. Look at all this SNMP server. It looks like everybody has created SNMP server. There's a number of, look at all these interfaces. There's a lot of stuff out there that people have been playing around with. So here's the running configuration. But this is an example of Napalm being used. So let's go take a look at how it's used. I'm just going to click and go to this code. It's in device info, which is in Quokka controller device info.py. And in this particular module, I have get Napalm device. So this is me using Napalm to get information from a device. I'm going to check the OS. If the OS that is set, and I'm using OS, maybe this is a poorer name than I should have. I'm thinking about it now. This is really the type of connection that I'm going to do. I think I kind of took a shortcut and allowed the OS to be NXOS-SSH. That's probably not the way that I would do this. If I was creating a product for real. The device operating system obviously is NXOS, and the mechanism for reaching it, or the driver for Napalm, would be NXOS SSH, but I kind of took the shortcut. And so here you can see I'm doing get network driver. Remember that? That's what we did before. And oh look, this is actually similar to what I did before. So if the OS is iOS, iOS XE, or NX OS SSH, then I'm actually going to go and I'm specifying the port. And if not, then I don't specify the port. This is actually pretty much similar to what we did before. So here I've called get Napalm device, and at some point in time I'm going to go out for the device and get fax. You can see down here I can say get device info Napalm. So something's going to come here. And remember I mentioned fax was kind of quirky in that it will get stuff from the database unless you specify get it live. So it will get stuff from the database. That's so that that initial screen didn't take very long. Initially, if I look at my Quokka, what would happen here is the very first screen that you would go to, it would not be this nice listing of response time, availability, etc., but it would be to fax. And if every time you went to that screen you had to basically wait through something like this, that was very unresponsive. So that's why I implemented fax originally the way that I did. But that's just historical. Here you can see get fax, get environment. I'm doing that when we do polling, getting interfaces, get the ARP table, get MAC address table, which I don't think anything in the user interface does. Get config, of course, is implemented, as is get interface counters. So here you see I'm making use of this Napalm thing, and if as long as it's supported in Napalm, then I'm returning this information. So yeah, and remember I mentioned the NC client. Here I'm doing NC client type stuff to fill in data. But we're talking about Napalm. This is the use of Napalm inside Quokka. Hopefully this gives you an example of how it might be used in a real world environment. Okay, so let's review what we talked about. We were talking about Napalm, and within Napalm we talked about how you get a lot of abstraction that you wouldn't get normally. Napalm handles the details of communication. It also handles differences between devices, and that allows it to support multiple products within a vendor, and even can support multiple vendors. So you get a lot of value. Now, in terms of communicating with a device, something like Napalm is able to use SSH. It's also able to use netconf. Sometimes it'll use NX API even. So it does give you that. That's what we talked about at the beginning. At the ending, we talked about how Quokka uses Napalm, and we looked at some examples of Quokka using Napalm. And in the middle, we talked about this Napalm example where we went through and communicated with two devices in 3 different ways, sometimes using NXOS with NX API and sometimes using SSH as our communication mechanism. And we created the device using the driver, and then we opened it, and we just did get fax, get interfaces, get VLANs. We didn't care what the device type was, what the communication mechanism was. We were able to get it. We learned a little bit about try except and catching exceptions and what to do with that. And we kind of forced you to learn a little bit about Python in general, so that you become a Python developer and not just somebody who can copy and paste code from a website or a blog post or whatever. So hopefully you're a little bit further down that path. Specifically, hopefully you understand about how Napalm works and the advantages that it brings to the table for you in terms of communicating with devices. Hopefully you'll be able to use this in whatever device communication application you happen to be building at whatever time that may be. So hopefully that was useful. Thanks for listening.